Okay, I'm going to start the demonstration of part of the homework 6. It's question number 12, according to the guide of this slide. All right. So what I have here is a churn project. This is not to say that you have to have the same process model as I do. You know, I kind of I kept everything that I used previously. You know, I demoed some of these for different purposes, but these nodes didn't do any modification to the data. It's most of these are exploratory, so connecting your later nodes to them will not be affected that so much. And then starting here, it's more of a relevant to this homework. And I use a drop node to exclude those variables that tend to have perfect correlation with some other variables, right? And based on the previous homeworks, you know that there are 4 types of usage variables, and they are different segments of the day as well as the international and domestic type. Well, you have 4 groups of variables recording the usage, and specifically the minute and the charge variables are perfectly linear based on homework, maybe homework 2 or homework 3. And so you either exclude one or the other type consistently, and it's really okay to do either way. Either reject all the or exclude all the minute variables or exclude all the charge variables. What I did here, so you use a drop. Drop is under modify, I think, the first one. Drop is dropping the variables, not the rows, right? Dropping the variables. And immediately after you drag the drop, a couple of things have to be changed right on. Let's see, drop from table, you need to change it to yes to really drop those variables that you select as yes, otherwise it won't do anything, right? And the default setting is no, just to make sure bad things don't happen even if you did something accidentally. So you need to override the first setting as yes to explicitly exclude those things that you want to exclude. And then rejected, make sure it's yes. So what does this do is it will make another copy of the data set and really explicitly exclude all the rejected variables. Previously, rejected variables are kept in the data set. You can see it, but it's not used by any model because the row is rejected. Here, to keep things clean, if I select yes for the rejected, those rejected variables are really going to be dropped. You can't see it anymore. Just to keep things clean, and after that, I think they're pretty fine. What I also did is I changed the hidden to no, so do not drop the hidden, so that I can detect any hidden variables if in case there is, but it's not going to be critical. So keeping things consistent, here I will change it to no, and then everything on this portion is consistent. And now it's time to configure which variables to drop. We'll go to the variables, based on everything is default, and default means no drop. Keep them. If you want to really drop a variable, you change it to yes. Or if you prefer explicitly to change the default to no, that means to keep everything, to keep those that you choose as no. That's fine. Here what I did is I dropped all the minutes instead of charge. It doesn't make any material difference. But my rationale is that if you, it also depends on the problem and the context. For the churn problem, typically the day minute, average day minute of a month is maybe 300 or 350 minutes. But the charge per minute is going to be a fraction of a dollar. Hey, else, a fraction of a dollar. So the typical average charge is going to be 40, 35, something like that, or maybe even 20 or 15. So the scale is smaller. I tend to prefer those variables that are of smaller scale than larger scale, just because in neural networks and in regression, smaller scale data works slightly better and tend to not have unexpected problems with the convergence of the model, just because the scale is smaller. It's close to zero. So I prefer anything that's closer to zero if it doesn't make any material difference. So that's why I did that. But you can feel free to experiment with different things. So that's what I did.
Well, if we already rejected
if you already rejected,
so we don't really need to do yes.
You don't need to, right?
If it's already rejected.
And here the rows for those that you rejected will be rejected.
Right.
Yeah, my rows are input, so I have to explicitly do that. Yeah. So delete this one, new one. Any questions about the drop? It's optional, and it provides an option. It provides a way of doing things that you can achieve in other ways.
Is it okay to do it like a stepwise regression, or
Oh.
before neural network?
Yeah. Yeah, you can. You can connect the stepwise regression to the neural networks, so that stepwise regression provides a means of selecting important inputs, right? It's optional, but you can do that. And stepwise regression will definitely not pick anything that are perfectly collinear in the final selected variables, just because the way stepwise regression will work, it's smart in a way that it will not pick correlated variables together. Yeah. Okay, so that's the third part of I think the prerequisite of the question 12. Now, what about the first two parts? Normalize the numerical variable and record the categorical variables. Turns out that neural networks does that, but you want to make sure that you understand that which part of the setting specify that these things are being done. If you add a neural network, and after connecting the path inside network is where you specify the specific network, and you have number of hidden units. But down here there is a input standardization option. By default, it selects standard deviation, which is the z-score standardization, and by default it's taken care of for all the inputs. You can choose to favor other methods. They don't make huge difference. They sometimes make different slight differences, but the way the difference is sort of created is not. There's no rules to judge. You just have to, see it empirically. So the default option will work. And then also, this is here. There's another selection to make for score. Standard deviation selects yes. Default is no. This is applicable to the score data set. The unseen part of the unseen data set when you score the model, right? If this is left as no, then when applying the neural networks to the new data set, the unseen data set to be predicted will not be standardized in the same way as variables are standardized here. So you want to be able to keep things consistent and change to yes if this model is ever selected as the best model to score. So just to prevent any catastrophe here, to make sure you have selected yes. And so that's one thing. The other is the recoding the categorical variable. Similar to regression, it is done automatically. If you go into the results part of the neural networks and you take a look at the parameter, this is initial parameter, and then you have another table of final parameter results. If you take a look at the parameter names, that includes the input variable name and the specific hidden unit that the path is connecting. And here you have the different states separated as different parameters. That means every unique level of the state variable, which is a nominal, every level has been recoded into a separate dummy variable to be included into the neural networks. So it's already done automatically. You don't have to do anything. Just by having nominal variables in the inputs, the model will do it. So to recap, for the three things, when you do the homework, you want to talk about it. You want to talk about it by saying that you have done these by which means. You've done the first and second because the model automatically does it. You have done the third, I'm talking about the prerequisite. You have done the third by either you use the drop node to drop them and you provide the screenshot, or you provide the screenshot of those variables that ought to be rejected, already has a row of rejected, and that means those variables will not be included in the neural networks. So that's the three, to fulfill the three prerequisites. That's what you do. You can say you use a stepwise regression, and then you can get the list of variables from the exported data set from the regression to say these are those variables that are selected retained, and those that have a rejected row are those that are rejected. So that would be sufficient. Any other questions?
Another question. On the output report on the model, it has some variables called bias.
Yeah.
What are
Yeah, I'm going to talk about it. Any other things about any other questions about the prerequisites?
Did you actually do any other transformation, or did you just use that to look at the
Oh,
distribution?
right. No, that was for exploratory purposes.
You just use it to look at
Yes. But as I said, that path is not, telling you should be identical with that, and that is just a leftover the previous nodes that I used. For your project, it's always a good practice to check for missing values, and necessarily if there's missing value, impute the values. Data partition is definitely necessary. And other things are dependent on the kinds of models that you do. If you use regression, it might be better if you have a transformation node that take the logarithm of those skewed variables just to improve the model. All right, now I'm going to talk about the topology. As I said, those two are straightforward. There's only one thing left over, and we'll just do it live on these two, and then to calculate it, and then get the results. You know, so you have two ways. One is to work with the imported data source or imported data to figure out how many inputs are there. So you have a neural network. After it's run, you can choose, from the property pane, you can get the imported data set, and then go into the imported data set, and then take a look at the variables list, and work out this formula. Sort of, this is not a complex math formula. Number of units equal you only focus on those with an input row, right? And you have three types of variables. Number of binary, each binary variable counts as one input neuron. Number of interval variables, each one counts as one neuron. And then for all the other, if you have any nominal inputs, then you need to know the number of levels inside each of the nominal input, and then add them all up. In this case, we'll demonstrate there's only one nominal variable. So I get the imported data. And it's okay to look at either. Preferably it will be train. Look at the properties, get the variables. And I don't have any rejected. I only have ID, target, and input. So only look for the inputs. Under the inputs, I have interval, binary, skip state for now, interval. So all the input variables that have other than nominal, I have 13, so I have 13 neurons for those. Then I only have to count the one nominal variable. I know that it has 51 or 50. 51. Yeah. I know it has 50 different levels. So it will be 50 neurons, 50 additional neurons in the input layer. So 13 plus 50 is 63. So in that case would be 63. And you can go the other way, but so the first one is more inferred, calculated, rather than based on the reports, based on the results. And the second approach will be based on the results, will be solid results. And turns out to be also 63, but you have to work through some math. You can go to the results and open this neural network results window. So two parts are similar or identical even. The lists are identical. One is parameter start, the initial values, which are randomly generated. The other is the final result. Question?
Yeah, if you look at the properties of the variables, if you ran a regression, I guess the regression will reject the sign rejects values, the ones that are not significant for you.
Yes. 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 Or if it's plain regression will not reject, but stepwise will reject, and not only, and depend on the setting, even significant, based on conventional standards, significant variables may also be rejected. Okay, neural nets. You can either look at the start parameter optimization start or optimization finish, or either result. Optimization results go from the top until you see bias. Before bias, you have a number. That is the total number of weight parameters. And this gives you information that's useful to calculate the number of input neurons. And so get this number, 189, divided by the number of hidden units that you have. And I know I had 3 here by specification. So divide that number by 3 is 63. So you get the same number. You can do either way or do both to just verify you have the correct number. So what is the bias here? The bias is the intercept, is equivalent to the intercept term of each hidden neuron. So each of the hidden neuron, accepts each of the hidden neuron is a linear combination of all the input neurons. So you have those connections. But in addition to all of those connections, you have an additional term which is similar to an intercept term of regression. So that's why you also have that, and that changes all the time based on the optimization process. The 3 you have 3 bias because you have 3 hidden units. So each hidden unit has 1 hidden bias. Yeah.
So does that mean like all the connections have the same, within the same layer have the same bias?
Well, not the connection have bias, but only the circles have its own bias. So by that, you will have the answers that you need. All right. Right. Any other questions about the homework?
Does the output, I guess you got churn, so you got true false.
Yeah.
So like on the report shows 4 variables.
Really?
Well, not.
In terms of the output layer, for its binary decision, so you have 2 output neurons. You have 4 results probably because of false positive, false negative. So you have both 2 by 2 scenarios. I'll talk about that. That's a major topic of today, and that's going to be fun, interesting to work through. Yeah, just hang on.
Stay tuned.
Great. All right. So that includes the sort of warming up for homework. I hope you can work through the homework without much problems. Refer to this video if you need guidance. And now I'm gonna pause the video for now. Okay, resuming the demonstration, we'll quickly demonstrate how to adjust the decision weights for the donation project. All right, so I'm going to close this project. So this example uses the PVA97NK data source. No, not that. Okay. So open that project if you have. If you don't have it, then probably you have to, do it on your own afterwards, and then, watch this video to follow. Open that, and you don't have to have the exact path as I do, as long as you have a few nodes. That should be good. Okay, so we're going to visit the portion of data source import that previously we simply put the number in or we skipped, and now we're going to visit those parts. For here, we have to visit the data source itself, not only the data node. So this one uses the PVA 97 data source, and you'll go into the decision ellipse. Here, all of these tabs are grayed out. I cannot click them because I haven't set up the decision properties yet. Because in the import data source step, I skipped that part. So now here we're going to revise it by build.
How do you get?
Yeah, you click the data source here, and then down you'll see a decision, and go into the decision ellipse. You'll get the decision processing. So this part, after you click build, you have option to change these parameters. And the part of tutorial is the page 35 of chapter 6. Okay, so I'm going to, for this demo, I'm going to skip the probability decision. Ideally, you would have done that as well, and that will follow chapter 3, I think. Okay, to modify the decision here. So this is the confusion matrix that we've been working with. We have to specify the name of the decision that corresponds to the label. Here it's the donation. That's target B, right? Target B equals 1 when the outcome is donor. Target equals 0 when the decision, the outcome is non-donor. For our decision, if we predict the person to be donor, then we would like to solicit. We would like to send a letter to solicit. So based on the tutorial, it's solicit. If our prediction is 0, meaning non-donor, we would be to skip or ignore the case. And so, yeah. And not quite yet, we haven't quite yet completed everything here. So whenever we see solicit, it's the decision of us based on the positive prediction. Now we have to change the weight here. By default, the weight is 0 and 1, and it's the same for, and that doesn't even make sense. You cannot accept the default here because this would be, and things are slightly misorganized here. You have 0 on the top and 0 on the bottom and 1 on the top. That's not the same as we did on the paper, but there's no way to change that here, so we have to mentally adjust. But the diagonals are true predictions. For the first diagonal, it's the true positive. 1 may make sense, but for true negative, it doesn't make sense to put a 1 there. It's going to be 0. It should be 0. Right, and then we'll have to revise the benefit and cost of the the solicit decision. In the case of true positive, we expect to have some donation, right? We expect to receive some donation, and based on the tutorial, it calculates the mean value of donation variable in the data set. It comes down to something like 16 or so. It's yeah, $16, 16 something, and we will have to minus the postage. The postage is about 68 cents. So here we would put 15.14 as the benefit, and minus 0.68 as the negative benefit, which is, you know, in the case of false positive, we mail a letter without hearing anything back. We don't have any revenue, but we're incurred a small cost. And if we ignore, there's no cost or benefit whatsoever, regardless of the outcome. So that's how. And by doing that, and make sure that, because there's no way to update the decision on the data node, make sure that it's the source of this node is the same source that we modified. I think somewhere data source, no, data selection, data source, that the one we modified is selected for this data node. Then that's how you can make be sure that whatever is modified in the decision is reflected on this data set. Now, once you do that, and if you train two models, two decision models, one is best classification decision, and you select the misclassification rate as the objective, and then you train another decision model where you choose the decision as the model selection criteria, right? And then you have a model comparison, which also choose profit or decision as the criteria. Then the best profit model will be selected, because on average it will have a higher average profit based on the weights that you assign to the different decisions. So that's it for today. If you hang out here more, I'm going to train two decision trees here, just as I said just now, and we'll see. I'll show the results. But if you're in a hurry, feel free to go. Right? And I'll just keep recording the session so that you can watch it afterwards. All right. So these, just to look at the missing values, data partition is done well. And then I'm going to, so log transformation, I corrected the distribution of those skewed variables. I'm going to follow these modifications by my new models. I'm going to put the models here. Where is he?
For the decision weights, do we need to have a minus value for the incorrect
Yes.
decision?
Did I not put the negative?
I didn't know.
Let's see. Yeah, you should.
Okay.
Because minus benefit is the cost. Yeah. Right.
Got it. Thank
Yeah.
you.
All right. So two decision trees. Let's see. So this is the best classification model, and I will select the model based on assessment, which means to look at the validation data set, and assessment measure would be the misclassification rate, which is the overall error rate, you know, disregarding the differences between false positive and false negative. And then I have another decision tree. Which will be the best profit tree. And for the best profit tree, I will select the decision here. The decision takes into account the cost and benefit. Now, I'll simply have another model comparison note. And I'll demo both ways. I'll first choose the misclassification on validation to see if the best classified tree will do better. All right, let's take a look at the results. It's the same. It's the same. Really? Or it's just the difference is at the more digits. Now here, anyway, the best classified tree is selected. I'll just go back to see the criterion that I chose and make sure they are right. Misclassification, decision. Yeah. It just happened that, you know, the data set is not making that much of a difference. But what if I change the criteria to profit? So average profit loss means to calculate the profit earned of the entire data set and divide it by the sample size. Now since we're working on the same data set, so it's just the total. You know, it's the same thing with the total profit. Let's see the results. Did I not change it? Wait. Selection criteria invalid. No.
Oh, maybe you didn't change the.
Here it didn't change. I changed this. Average profit loss. It should have been changed. Let's see.
But the data's still there, right?
Huh?
But can you still see the average profit loss?
Yeah, I selected average profit loss.
No, I mean in the table, even though it's not a selection criteria.
I should be able to see it, right?
Column, right?
Yeah, let me make sure. Average profit loss, and that's the right thing. Mean response. Great. Yeah. So let's see. Validation. Do you see it? Validation.
Or is it because it's not available?
Not likely. Model description, label, selection, criteria. Well, let's see. Validation. See. This is fine. Average profit loss. Or the decision.
When you click the ellipse on the decision indicator,
The decision might have something to do with that. Here it's good, but
sometimes I change the data
does
source,
it?
but
Yeah,
no,
I
it's
would
not
try that.
change.
Well, no, the data source still
You click
points
the
to
ellipse on the decision there.
the right. No, not the data source is good, but still I don't see the result.
Can you,
So I would just replace it.
yeah. Because sometimes I recheck the variable, and I tried to update the node of the data source, but it still didn't copy over.
Yeah, I know. So let's see. Where's my model? Okay, good. We'll try again. Yeah, and it makes sense because if the weights are not specified, then the decision criteria is the same as misclassification.
Yeah.
But if the weights are, in effect, the decision will consider the profit. So, and that's why we see the misclassification rate the same.
And I think if the average profit loss is not available in the result.
Yeah, it's
because
not available.
We haven't built that.
Yeah, so that means the weights are not available. That's a good diagnosis. And we'll see. Yeah. It's the same.
No, it's big.
Oh. But the
Yeah,
misclassification.
it's the same. Why? What about validation misclassification rate?
There's a difference.
That's different.
But it's
Different by a large margin. Interesting. Very interesting. This is the same. So if we base the decision on this classification rate,
then of course
the best classification tree will be chosen. Yeah, it's mysterious. Earlier, what I did is using the donor raw, which has clean variable names. The variable names are easier to read, and in that case, I think it's the first. See it, right? I think it's this one. So what I did here, this one originally had the decision weights, but it's slightly different. So to see that, I had the 14th and versus minus 0.5. It's very similar to what we what here what it showed.
Do
So
we need to change anything in the decision time? The third one?
that's possible. The probability, you mean?
Yeah.
Yeah, that's possible. Here it does have the new setting. It adjusts for prior, and that's beyond the scope of what I'm planning to talk about, but it may have some influence there. So here, after I run it, I chose the profit, and the difference is you have some difference there. So it's it's some fraction of the and this is average. This is average profit. If you have a large base, then the difference will be more clear. But so the best classification
Yeah.
is to best mean profit. Best mean profit has slightly higher average profit, but it has validation. It has slightly higher misclassification rate. So the error rate is higher, but the decision is better. So in this case, it makes sense. Wait, not twain here, right? So it's even though it's making more mistakes, but the decision is better. Great. I hope this illustrates. All right, we have finished our demo. See you